here we are. All right, so in this video, we're gonna look at this problem that for some reason has become some type of sensation or issue, or I don't even know how to explain why this problem has become what it's become on the internet, other than people they think they understand math, but they don't, to a certain degree, right? So in this video, I'm not gonna be worried about your feelings. I need you to just put your feelings to the side and come into this video with the idea that, all right, I'm open, even if I'm not doing this right, and the way this person shows me and tells me, and the conclusion they arrive to is different than mine. I'm open to trying to understand their logic and their reason behind this, because that's how we progress in science. And we say, okay, I think this is this because of this. And then when you hear a sound argument that you cannot refute with anything that is objective, you say, I reserve the right to change my conclusion based on new evidence and new information. So if you're wrong and you know you're wrong and you're not changing your conclusion simply because you were wrong and you want to be hard-headed, then just go ahead and just click off now. I don't want your view. Just go away. Just go find something that reinforces what you think and live in that bubble, and that's perfectly fine. So to get started with this, there's something that we need to address. This is the very first thing, is that this division operator, and what I mean by operator is this thing right here. That's a division operator. This is an addition operator, all right? And parentheses, this is how we group terms. We're grouping things, saying this is all one thing, right? So let's unpack this. But also, we also know that a number next to a parentheses means multiplication. That is, it's just shorthand for 2 times 1 plus 2. Or if you're not worried about variables, 2 times 1 plus 2, right? But when you start getting into algebra, this looks like 2x times 1 plus 2, right? So we all know that this is multiplication. Like, we're cool with that. And I see a lot of people building an argument based off of this implicit multiplication, saying, well, we all understand that this is multiplication, right? It's implicit, which means it's something that everybody knows that we're doing, but we just don't write it because we're using shorthand. And they take that and then they say, so, it's perfectly reasonable to say, which means we also know that there is implicit parentheses here. No, absolutely not. Okay? That is not what's happening here, all right? Whoever wrote this problem knew how to use parentheses. And they put them where they are and not anywhere else because this is the problem they wanted. Okay? If they wanted to, they could have written 6 divided by 2 times 1 plus 2 equals whatever. But they didn't. They only put parentheses in one spot. So anyone telling you that this problem is worded ambiguously and they understand why you're confused is saying that so that they don't hurt your feelings. That's really all it is. Because this is not worded ambiguously at all, okay? This may be using archaic symbols and operators, right? The archaic symbol for the division operator, and by archaic, I mean once you get into upper level math or physics or in science, this is virtually non-existent, right? We know what it means, but I haven't seen it since before college math or science, right? And My background is a bachelor's degree in both mathematics and physics, and I'm starting my PhD in mathematics in the fall because I just love mathematics. Okay, so just leave it at that. This right here is, we don't use it. And if you look at symbolic computation engines like Mathematica or Maple, if you look at these things, if you type in 6 and then you hit the sign for division, what it does is it says 6 over, and then it gives you this box because now you're populating this box, right? So it automatically converts it to a fraction because it knows that this means you're dividing, right? So let's just get into this. So I'm going to say, get out of that. So right off the bat, let me write this down. 6 divided by 2 times the quantity 1 plus 2 is not equal to 6 divided by the quantity 2 times the quantity 1 plus 2. These two things are not equal, okay? But we're going to work them down on both sides, all right? So using your order of operations, parentheses, exponents, and then multiplication and division together are on the same level, and then addition and subtraction, right? So parentheses. All right, on the left side, we're going to do 6 divided by 2. Now we work out what's in here. So this is going to be times 3 is not equal to 6 divided by. So then we have 2 times 3. Now over here, these parentheses can drop because we know this is multiplication. There's nothing left to do inside the parentheses. The operation of parentheses here, like grouping this term together, you're done. So you don't need the parentheses anymore. So this becomes 6 divided by 2 times 3. All right? Now over here, you still have an operation inside of a set of parentheses, your outer parentheses. So 2 times 3 is going to be 6. All right? Cool. So I'm just going to rewrite this because, well, no, I don't need to rewrite it. We can just keep working down. So now on this side over here, you have two operators, division and multiplication. Now these are on the same level in the hierarchy, so you work them left to right. Okay? So if you're in a part of the world that works from right to left, then this would be written as 6 divided by 2 times 3 equals. So don't give me this argument like, oh, well, we're working it right. We can work it right to left in some places. Well, then they're going to switch. This expression will be flipped, right? So I don't want to hear that argument. So we're going to work this from left to right. So 6 divided by 2 is 3 times 3. This is not equal to 6 divided by 6. Now we can drop these parentheses. Let's just drop the parentheses on this term because there's nothing left to do inside the parentheses. So 6 divided by 6. All right. Now 3 times 3 is the only operation here. 9. 6 divided by 6, 1. Now this is equal to this, which is what we were given to start with. This is equal to 6 divided by the expression 2 times the expression 1 plus 2, all in those parentheses. So by adding an extra set of parentheses, we have changed the structure of this expression. All right? So this is equal to 9. It is not equal to 1. You cannot just add parentheses. That's because parentheses were not given here. All right? So just because we know that we do explicit multiplication or implicit multiplication here, that doesn't mean we can just say, oh, well, we can implicitly add parentheses. No, that's not how that works. If you want to look at a more abstract example, right? then you can say A divided by B times C plus D is not equal to A divided by B times C plus D. Like, these things are not equal. It's just not, okay? So there's too much of people who think they understand math, who really didn't like math to begin with. They didn't like it in school. They don't like anything more than the math of calculating their paycheck and how much overtime they're going to get, which is cool. No problem. Like, math isn't your thing. That's cool. But then don't come on the internet and act like it's your thing, because it's not. Because it's our thing. It's what we do every day. All right? So another thing, dealing with these parentheses and exponents and things of that nature, since we're on the topic real quick. If you have 3 plus 5 squared, this is not equal to 3 squared plus 5 squared. Parentheses come first, all right? So this is going to be equal to 8 squared. This is going to be equal to 9 plus 25. 8 squared is 64. 9 plus 25 is 34. So again, the order of operations matters. If you try to say, oh, well, this is just squaring each term and adding it, which is what we have here, you're wrong, because of the order of operations. All right, that's just how it works. Now, let me give you an example of all of this stuff, not written down by hand, but in code. We're going to see how it works in code. And I'm going to show you that parentheses is implicit multiplication. And unless you understand that you're just saying this is shorthand for the multiplication sign, then you can get stuff wrong in other places as well. And I'm going to show you that by adding an extra set of parentheses, you will change the outcome. All right. So let's go ahead and open up our Jupyter notebook for our iPad. We're going to have a new notebook. So let's go ahead and just get in here. Now, what I'm saying is this. Let me just go ahead and put this in here so we can all see. So we are saying that 6 divided by 2 times 1 plus 2 is not equal to 6 divided by 2 times 1 plus 2 altogether. Now, if I didn't make any errors in this markdown code, then this is going to look right. All right, there we go. This is what we're going to show. We're going to show these two things are not the same. All right, so for any of you that's curious, let me get it to open back up. If I can, there we go. This stuff in here, this is basically what's called Latex. And I could put some links if you're interested in learning how to type this kind of stuff. So let me just make this a comment. So it's called Latex. And I'll put some links in the description so you can go learn more about LaTeX. And if you're a student, there's a site called Overleaf that allows you to have access to a free LaTeX compiler. This is awesome if you're in STEM. I will leave links to all this stuff in the description. Anyways, let's look at this. 6 divided by 2. Now, I'm just going to put the parentheses here. I'm not going to put a multiplication sign. And let's see what happens. Oh, hey, what? We don't understand. You need to tell us what it means to be 2 parentheses something, right? Okay, cool. So let's do this again, but let's put a multiplication sign between that 2 and that parentheses. 6 divided by 2 times parentheses 1 plus 2. Run cell. 9. And that's the same problem that we're seeing on the internet, right? Now let's try it again with these extra magical parentheses that people say you can just throw in there and it doesn't really mean anything, right? So let's say 6 divided by parentheses 2 times parentheses 1 plus 2. Okay, so maybe, okay, we don't have to do this multiplication because it knows, right? Well, you're gonna get the same problem. You have to know that it's multiplication. We as humans know it. The programming, the code is like, what? Now, if you are in a symbolic computation engine like Maple or Mathematica or Symbolab or Wolfram or whatever, then it may recognize this because it's built into it to recognize it, right? But this basic stuff in Python, it's not, you have to tell it that it's multiplication. So, and that's the same for other languages as well, right? If there's a language that you don't have to tell it, then let me know. I'd be interested in exploring that a little bit, but you have to tell it, right? It's the same thing that like you have to say 1 plus 2 inside here, or else it's like, what are you talking about? So let's run this and see what happens. 1. Oh my, okay. So then let's do, I haven't checked this yet, but let's see what it does. 2 times 1 plus 2, and let's say equals equals. So it's going to say whether or not this is true, right? And let's put it to itself just to make sure that it's going to give us whether or not the evaluation of this expression is true. Times 2 times 1 plus 2. True. Okay, that's true. Cool. Now let's do the same thing, except we're going to use the new thing that people think you can just make up and just throw in parentheses everywhere you want. 2 times 1 plus 2. Let's see what this says. False. These things are not true. You can't just add these things together, right? So the last thing that I will leave you with is this. Let me show you why these parentheses act the way that they do. So let's say we have 2 times 3, which is this thing right here, okay? So we have 2 times 1 plus 2, all right? That's equal to 2 times 3. I could also say this is equal to 2 times, or parentheses, 4 minus 1. Or, I don't know, 2 times 30 minus 27. What you're doing is you're saying, okay, we can rewrite 3 as many different things. You can even put like some type of limit in here, right? So you could have something like 2 times 3 is equal to 2 times, I don't know, I'm trying to make something off the top of my head. The limit as n goes to infinity of 3n plus 1 all over n. Well, that's just 2 times 3. Because if you know about limits at infinity and you know the tricks, then you know that leading powers, if they're the same, then it's going to be this leading term, right? So if this was like 3 over 4, then this would be 3 over 4, right? But that's not what we have. So what I'm saying is these parentheses, they're simply a placeholder for what the eventual evaluation of the expression inside them will be, right? So if you say 3 is equal to a plus b for all a, b, for all variables a, b that are in the real numbers, then 2 times 3 is equal to 2 times a plus b, right? So this is like 3 equals a plus b such that for all a, b, and r, right? I mean, really, you would write it this way. For all a, b, and r, A plus B equals 3, right? So I'm just saying, like, this is a placeholder. That's it for something else. Whatever's inside of there was one thing, and it's been broken up into these multiple things, and it's these parentheses are telling you this is all part of one thing. So up here, this is a placeholder, and it's saying the parts inside equal to one thing. And if I'm not mistaken, that's algebra, the sum of the parts, right? So these are all the parts of 3, and you sum them up to get 3, right? This is some very basic stuff. So next time somebody tries to tell you that the answer to this is 1, tell them, look, I understand why you may think the answer is 1. I get it. But what you're not understanding is, why is this not? I'm getting distracted. My ADHD is taking over. What you're not understanding is the order of operations and how these things, you can't just throw stuff in there, all right? Feel free, if you don't want to argue with them, or if you're trying and you just can't, then send them my way. I'll talk to them in the comments. They can watch the video. If I need to make another video going further into depth about something particular, then I'll make another video for it. But feel free to send them my way, because this isn't about feelings. This is about, look, this is how we do it. And if somebody's trying to make the argument, this is ambiguous. No, it's not. Just stop, all right? Whoever wrote this knew how to use parentheses, all right? They were counting on the fact that a lot of people misinterpret either the order of operations, or they haven't done math in so long that they're rusty. Like, it's not their fault. They don't do math on the daily. And this is one of those things that takes advantage of that. So just stop. Send them this video and we'll get it straightened out. And if there's more questions, then we will answer those questions. All right? So I hope this helps explain things. I hope this provides some examples you can show someone for why it is the way it is, and not just, you can just randomly do whatever you want. If not, if you don't think I was clear about something, let me know in the comments. If you don't like this video, by all means, hit the thumbs down, do whatever you got to do. But if you want to see a video about some other controversial thing or whatever, just let me know in the comments and I'll get that up. And then, yeah, we'll try to fix some stuff, but it's going to be hard. See you soon.